Hello, welcome to this proof by contradiction video. I'm going to try to prove by contradiction that root 3 is irrational. I'm going to do this a particular way. It might be different than another way you might see, but hopefully this one will make sense. I like this method. Now, firstly, we make our assumption. We write the word assume, and we assume the opposite. So I'm going to assume that root 3 is rational. I'm going to assume the opposite. And therefore can be expressed, can't see because of my pen at the moment, but I will move out of the way, can be expressed in the form, go for P over Q, doesn't really matter what the letters are, where P and Q are integers and P over Q is a fraction in its lowest terms. What I mean by that is just a fraction that can't be simplified. Okay, well let's start off. Let's start off with playing with the algebra. So we'll say, okay, P over Q is root 3. This is a fraction. If I say P squared over Q squared is 3. So P squared is 3 lots of Q squared. Just put a line under that bit. So there we are. That's the first bit. So we just square both sides and then we rearrange a bit. Now, let's have a look. We're going to do the old odd even thing. So I'm going to first look at the case of Q being even. So consider if Q is even. Well, if Q is even, then Q squared is even. And naturally, that would mean 3Q squared is even. I think we can accept that because if I square Q, I square an even number, I get an even number. I multiply it by 3, I've got another even number. Well, if that's the case, P squared equals 3Q squared, I'm going to say, okay, P squared is even. Now, if P squared is even, then we know P is even. So I've got P and Q both even. So that means P over Q is even over even, which can be simplified. I can simplify any fraction that's got even over even by dividing through by 2. Therefore, we have a contradiction. Now let's consider if Q is odd. So imagine Q is actually odd. What's the case then? So if Q is odd, well, we've still got P squared equals 3Q squared. We're going to say, okay, let's say, so if Q is odd, then Q squared is odd, then 3Q squared is odd. Q's odd, square it, another odd number, then 3q squared is odd. So we know that if 3q squared is odd, p squared must be odd. So p squared is odd, and the only way I can produce an odd number by squaring is if I square an odd number. So I've got a kind of chain of events here. We're saying q is odd, q squared's odd, 3q squared is odd, that means p squared's odd, which means p is odd. Just by starting with q is odd, squaring it, multiplying by 3, still got an odd number, that must be odd, and with that. So that means we're saying p and q are both odd in this case. Well, what happens? So let's say, okay, let p equal, say, 2m plus 1. Let q equal 2m plus 1. So we've got different odd numbers. We're saying where m and n are integers. Okay. So let's have a look. Let's say, so we had p squared equals 3q squared. Let's replace that with 2m plus 1 squared equals 3 lots of 2m plus 1 squared. So I've got 4m squared plus 4m plus 1 equals 3 lots of 4n squared plus 4n plus 1. 4m squared plus 4m plus 1 equals 12n squared plus 12n plus 3. Simplify a little bit. I'm going to get rid of that 1. 4m squared plus 4m equals 12n squared plus 12n plus 2. Hopefully you can follow the algebra. I'm going to half both sides. I can do that. So that's 2m squared plus 2m equals 6n squared plus 6m plus 1. Maybe you can see what's going to happen here. It's pretty exciting. 2 lots of m squared plus m. I've got an even number on this side. So I know that's even. And then I've got on this side, lo and behold, an odd number. Because 2 lots of something, even, plus 1. And if p and q are odd, we have a contradiction. Okay, so more or less the job is done. We have a contradiction. Therefore, root 3 must be irrational. Any number that's not rational is irrational. And we've just shown we can't have a case where it's rational. If we assume it's rational, we create a contradiction. Therefore, we know it's irrational. Proved by contradiction. Just have a little look again through this. We write our assumption. We then define it as p over q. There's a lot of proofs like this, root 2, root 5, root 7. They all follow the same pattern and they like them in exams. So if you learn this logic, you should be able to do any of those. The p squared equals 3q squared becomes really useful. We then consider the case where q is even. If q is even, we find out chain reaction tells us p is even, and that leads to a contradiction because we've defined it as p over q, a simplified fraction. If I've got even over even, I can simplify it. I've contradicted my assumption. We assume it's odd. Chain reaction, if you like, again. If q's odd, p's odd. So we've got odd numbers. I define them as 2m plus 1 and 2m plus 1. I do the algebra and I get even equals odd. Well, even does not equal odd. That's a contradiction. And that gives me my proof. Okay, I hope that makes sense. Thank you very much.